Assalamu alaikum everyone. Welcome to Explore Chemistry. I am Manaj Kamran here with a very important and somehow difficult topic regarding acid-base theories. But I assure you after watching this video, this topic won't remain difficult for you people. So let's start. This is the continuation of one of my previous video where I explained you the first theory of acid bases and which was Arrhenius theory. So here I am going to give you a short description of that theory. According to Arrhenius, acid was a hydrogen ion producer in water and bases were hydroxyl ions producer in water. According to Arrhenius, acids were those substances which can give hydrogen ion in water and bases were those substances which can give hydroxyl ions in water. There were some limitations of this theory. Actually, this theory was applicable on aqueous solutions only. It cannot include non-aqueous reactions and this theory cannot include compounds like copper sulfate, aluminum chloride, carbon dioxide, which were not having any hydrogen or hydroxyl ion. So after this theory came another theory which was a broad concept of acid and base. It was Bronsted-Lowry theory. This theory was given in 1923 by a Danish chemist Johannes Bronsted and English chemist Thomas Lowery. They were working independently, but these chemists proposed the same definitions for acid and bases. According to their definition of acids and bases, acids are those substances which can donate hydrogen ion or proton in any chemical reaction, and bases are those substances which can accept hydrogen ion or proton in any chemical reaction. Hydrogen ion is also known as proton because this is the structure of hydrogen atom in which there is one proton only and one electron. But after losing this one electron, the structure of hydrogen ion will become like this. In this structure, you can see there is no electron, only one proton is present. So therefore, hydrogen ion is also called as proton. So this theory was based on proton. According to this theory, proton donors are acid and proton acceptors are base. So in this diagram you can see, in this cartoon you can see the species which is donating hydrogen ion, it is considered as donor, and the species which is accepting hydrogen ion, it is considered as acceptor. So according to the definition, donor will be called as acid and acceptor will be called as base. Let me explain you this concept in detail. This theory includes all the acids and bases that Arrhenius defined. It also includes some compounds that Arrhenius did not classify as base, and this theory was not based on aqueous solution. For example, when ammonia dissolves in water, hydrogen ions are transferred from water to ammonia to form ammonium ion and hydroxide ion. This concept was given by Arrhenius also. So Bronsted-Lowry concept also includes the previous concept of Arrhenius. Let me explain how. This is the reaction of ammonia and water. In this reaction, you can see water is donating its proton to ammonia and ammonia is converting into ammonium ion after gaining that one proton. From NH3 to NH4 it is converting, and water is converting into hydroxyl ion from H2O to OH after donating one proton. So according to the definition, water is donor of proton, so it is considered as acid, and ammonia is acceptor of proton, so it is considered as base. Ammonia is a Bronsted-Lowry base because it is accepting hydrogen ion or proton, and water is a Bronsted-Lowry acid because it is donating hydrogen ion or proton. But this reaction is reversible reaction. There is also acid-bases components on the product side. If you will see the reverse reaction or you will see the product side, you will identify that there is a proton transfer taking place from ammonium ion to hydroxyl ion. Therefore, it will convert back into reactants because this is reversible reaction. So, in reversible reaction, ammonium ion is donor. So, it is considered as acid. So, in reverse reaction, we called it as conjugate acid. And hydroxyl ion is considered as acceptor because it is accepting proton and converting back into water. So it is considered as base. In reverse reaction, it is called as conjugate base. So NH4 donates a proton and NH4 ion is the conjugate acid and hydroxyl ion is the conjugate base. Let me give you the definition of conjugate acids and bases. Conjugate acids can be ion or molecule formed from a base. Actually, it is the part of base, but it is formed when base gains hydrogen ion by an acid. Therefore, it is called as conjugate acid. Like in the previous example, NH4 was conjugate acid of base NH3. So, you can see it is the part of base, but it is formed because of acid, because acid donates hydrogen ion, therefore it is known as conjugate acid. And conjugate base is a species, it can be ion or molecule that remains after an acid donates a hydrogen ion to a base. So it is formed because of base, but it is the part of an acid. So hydroxyl ion here is a conjugate base of acid water. So here you can see hydroxyl ions came from acid. It was a part of acid, but it is formed due to base, therefore it is called as conjugate base. But if you have to identify conjugate acids and bases, you must have to see reverse reaction. So you can easily identify conjugate acids and bases. Now let me explain Bronsted-Lowry concept in detail. This is another example when HCl, as you know it is acid, reacts with water. In this equation, HCl is donating proton to water. So HCl is considered as donor and acid and water is considered as acceptor or base. In this reaction, hydrogen chloride is the hydrogen ion donor. And by the definition of Bronsted-Lowry, it is considered as acid. And water is hydrogen ion acceptor. And according to the definition of Bronsted-Lowry, it is considered as base. And if you see reverse reaction, one proton is donating from hydronium ion H3O positive to Cl negative. So H3O positive is donor and chloride ion is acceptor. So it will called as conjugate base and hydronium ion H3O positive will called as conjugate acid because it is donating. So you must have noticed one thing in both the example. In this example, water is acting as a base. Sometimes water accepts a hydrogen ion and acts as a base. But in this example, it was acting as an acid by donating hydrogen ion. Water can act as base as well as acid. Such type of substances are called as amphoteric substances. How water behaves, it depends on the other reactant. If other reactant is acid, so water will act as a base. And if other reactant is base, so water will act as acid. You can see the difference in both the examples. So water can behave as both acids and bases, and such type of substances are known as amphoteric substances. Amphoteric substances are those substances which can act as either an acid or a base. Like water is amphoteric substance. In the reaction with hydrochloric acid, water accepts a proton and is therefore a base. In the reaction with ammonia, water donates a proton and is therefore an acid in that reaction. Amphoteric substances are just like amphibian which can breathe under water and on the land. Amphoteric substances can act either as an acid or a base, depending on what other substances they are reacting with. Now, how will you identify that any substance is an amphoteric or acid or base? You can easily identify acid and base. For identifying amphoteric substances, you must have to see two things. If any species having hydrogen ion, so it can donate that hydrogen ion and act as an acid. If the same species also having negative sign or lone pair, so it can accept a proton or donate that lone pair and can be considered as base. So species having both type of properties, having proton to donate and having lone pair to donate, can be considered as amphoteric substances. Apart from these substances, oxides are also amphoteric in nature. These oxides are some metallic oxide like zinc, tin, lead, aluminium and beryllium oxides form amphoteric oxides. They can act as acid as well as base. Remaining all metal oxides are considered as basic in nature, and non-metallic oxides are considered as acidic in nature. So all the metallic oxide except for zinc, tin, lead, aluminium and beryllium are basic in nature, and all non-metallic oxides are acidic in nature. And these metal oxides, zinc oxide, tin oxide, lead oxide, aluminium oxide and beryllium oxides are amphoteric in nature. There were some limitations in Bronsted-Lowry concept. The protonic definition cannot be used to explain the reactions occurring in non-protonic solvents such as CoCl2, SO2, N2O4, etc. Means it can define those substances only which is having a proton, and those substances which are not having any proton, which cannot donate or accept proton, they cannot be classified as acids and bases according to this concept. It cannot explain the reaction between acidic oxides like carbon dioxide, sulfur dioxide and the basic oxides like calcium oxide, magnesium oxide, which take place even in the absence of solvent or in the absence of proton. In this example, there is no proton transfer take place, you can see. So this concept cannot explain such type of substances as acid or base. Moreover, substances like BF3, AlCl3, etc. do not have any hydrogen and hence cannot give a proton but are known to behave as acid. And this theory was failed to explain such type of substances. So, the next concept was Lewis theory. It was given by Gilbert Newton Lewis. He was an American physical chemist whose concept of electron pairs led to modern theories of chemical bonding. His concept of acids and bases was another fundamental contribution. He invented electron pairs. In this diagram of ammonia, you can see bonded pair and lone pair were highlighted. His definition of acids and base is more general than those offered by Arrhenius or by Bronsted-Lowry. The Lewis definitions include all the Bronsted-Lowry acids and bases. It also includes some compounds that Bronsted-Lowry did not classify as acids or bases. So let's study this concept now. According to Lewis theory, acid is a substance that can accept a pair of non-bonding electrons, that is also called as lone pair of electrons, to form a coordinate covalent bond. You must have studied this concept in coordinate covalent bond. And base is a substance that can donate a pair of non-bonding electron or lone pair of electron to form a coordinate covalent bond. Again, in this diagram, you can see this pair is not bonded. This pair of electron is not bonded with any element. So it is called as lone pair. Whereas these pairs are involved in bonding between nitrogen and hydrogen. So they are called as bonded pair or shared pair. But this pair is known as lone pair. So this theory, Lewis concept, was based on lone pair. According to this concept, lone pair donors were bases and lone pair acceptors were acids. Let me explain this concept in detail. This is a reaction between water and hydrogen ion. Water is having two lone pairs. If it will donate one lone pair to hydrogen ion, and it will form, after donating this lone pair, it will form a coordinate covalent bond between water and that hydrogen ion. This arrow is showing the formation of coordinate covalent bond and lone pair transfer from oxygen atom of water to hydrogen ion. In this example, hydrogen ion is acting as acceptor of lone pair, so it is considered as Lewis acid, and water is acting as donor of lone pair, so according to the definition of Lewis, it is considered as base. And the product form is known as adduct. The name of this product is hydronium ion. Hydrogen ions, which is actually taken from dissociation or ionization of water. This hydrogen ion is electron pair acceptor and the Lewis acid, and water is electron pair donor and the Lewis base. Let's see this through one more example. Here, ammonia, nitrogen from ammonia is donating its lone pair to hydrogen ion and forming ammonium ion. So ammonia is donor of lone pair, it is considered as base, and hydrogen ion again is acceptor here, so it is considered as acid. Product forming here is ammonium ion with overall positive charge. Hydrogen ions form the dissociation of water. Again, I am telling you this hydrogen ion came from the dissociation or ionization of water. This hydrogen ion is electron pair acceptor and Lewis acid, and ammonia is electron pair donor or Lewis base. This electron pair is actually lone pair, which was not involved in any bonding. Now, how will you identify Lewis acids and Lewis bases? A Lewis acid it can be any species, it can be molecule or ion, which can accept a pair of electron. That is, electron deficient species are considered as Lewis acid. If it is a molecule, its central atom should have incomplete octet like this. In case of AlCl3, aluminium belongs to 3A group of periodic table and it has only 3 valence electron. It will form an ionic bond with chlorine, so it has donated its electron to chlorine. So its central atom is having incomplete octet. It can be considered as Lewis acid. It can be considered as electron deficient, so it can accept electron pair in any chemical reaction. Moreover, cations which are having positive charge, they can be act as Lewis acid because they are electron deficient. Lewis base can be any species, molecule or ion that can donate a pair of electrons, that is electron rich species. So Lewis base should be electron rich species. If it is a molecule, its central atom should have complete octet. In this example, you can see nitrogen is from 5A group of the periodic table. It is having 5 valence electron. Out of 5, 3 electrons are involved in the formation of covalent bond between nitrogen and hydrogen. So it is having 5 electrons of its own and it is taking 3 electrons from covalent bond of hydrogen. So its valence shell or octet is complete, having 8 electrons. So it can be considered as electron rich species. It can act as Lewis base by donating this lone pair. Similarly, anions which are electron rich having negative charge on them, they can be act as Lewis base by donating a lone pair. If you understood this, identify the Lewis acid and Lewis base in the reaction between ammonia and boron trifluoride. Identify the reactant with the unshared pair of electrons and the reactant that can accept a pair of electrons. If you will identify this, you can easily identify which substance will be acid and accept a lone pair and which substance will be base and donate a lone pair. If you have identified, you must have written this equation. In this equation, nitrogen is having lone pair, therefore it will donate that lone pair. And boron is from 3A group. It is its valence shell is incomplete, so it will definitely accept a lone pair. Ammonia is donor, so it is considered as base. BF3 is acceptor, so it is considered as acid, and both will form product NH3BF3, which is also known as adduct. Ammonia has unshared pair or lone pair of electrons, so it can donate that lone pair and can act as base, and boron atom can act as acid by accepting that lone pair. So from these three theories, we got three definitions of acids and bases. This table compares the definition of acids and bases according to all three theories. First theory was Arrhenius theory. According to Arrhenius theory, acids were hydrogen ion producer and bases were hydroxyl ion producer. Second theory was Bronsted-Lowry theory. According to that theory, acids were hydrogen ion donor or proton donor and bases were hydrogen ion acceptor or proton acceptor. Third theory was Lewis theory. According to this concept, acids are electron pair acceptor and bases are electron pair donor. The Lewis definition is broadest definition. It extends to compounds that the Bronsted-Lowry theory does not classify as acids and bases. So, Lewis theory is the complete theory of acids and bases. I hope you understood everything. If you did not understand any concept, you can ask me in comment section. Please like, share and subscribe. Thank you.